One of the things that many astronomers enjoy is getting pictures of deep space, mainly because it's only via things like the Hubble Space Telescope and soon the James Webb Telescope that we can see them or sense them at all. And while it may not capture everything going on for one reason or another, make no mistake, the images it does get can be quite breathtaking, such as with a certain laser jet that it detected after a tantrum from a star. And now everyone is talking about it. Allow us to show you how the Hubble telescope captures spectacular laser-like jet from infant star. The jet. The Hubble Space Telescope captured a laser-like jet that represents a tantrum being thrown by an infant star. The outburst came from a very young star just starting its evolution, and the image shows a jet of gas traveling supersonically. The glow you see in the image comes from the jet colliding with gas and dust around the star. Officials at the European Space Agency, ESA, wrote in an image description on March 7th. The result, the officials added, is the colorfully wispy structures, which astronomers refer to as Hubble haro objects, billowing across the lower left of this image. Hubble haro objects are bright patches of gas or nebulosity near newborn stars. It's not the first time Hubble has caught this object on camera. The telescope trained its eye on the area called HH34 between 1994 and 2007 and in extreme high definition in 2015, ESA noted. HH34. HH34 is about 1,250 light-years from Earth and resides in the famous Orion Nebula, which Hubble has also imaged many times over the decades. Orion is noted for its starbirth regions, and Hubble has an advantage in looking at the nebula. It's the closest stellar nursery to Earth. ESA added that the new imagery will be helpful for potential future science with the recently launched James Webb Space Telescope, which is in a commissioning period until about June. Webb, which will observe at predominantly infrared wavelength, will be able to peer into the dusty envelopes surrounding still-forming protostars, revolutionizing the study of jets from these young stars. ESA officials wrote, Hubble's high-resolution images of HH34 and other jets will help astronomers interpret future observations with Webb. And that's honestly what they want. Between these two telescopes, they want to not only learn more about space, but be able to interpret all that's going on within these nebulas and other entities. So, while some of you might just see a beautiful image, NASA and others see the potential for growth in science as a whole. But that's not the only sighting/discovery that the Hubble has been making as of late. It's been a busy telescope. Kilonova explosion. A kilonova occurs when two neutron stars, some of the densest objects in the universe, merge to create a blast 1,000 times brighter than a classical nova. In this case, a narrow, off-axis jet of high-energy particles accompanied the merger event, dubbed GW170817. 3.5 years after the merger, the jet faded away, revealing a new source of mysterious X-rays. As the leading explanation for the new X-ray source, astrophysicists believe expanding debris from the merger generated a shock, similar to the sonic boom from a supersonic plane. This shock then heated surrounding materials, which generated X-ray emissions, known as a kilonova afterglow. An alternative explanation is materials falling toward a black hole, formed as a result of the neutron-star merger, caused the X-rays. Either scenario would be a first for the field. The study was published on February 28, 2022 in the Astrophysical Journal Letters. We have entered uncharted territory here in studying the aftermath of a neutron-star merger, said Northwestern's Aprajita Hajela, who led the new study. We are looking at something new and extraordinary for the very first time. This gives us an opportunity to study and understand new physical processes, which have not before been observed. On August 17, 2017, GW170817 made history as the first neutron-star merger detected by both gravitational waves and electromagnetic radiation, or light. Since then, astronomers have been using telescopes around the world and in space to study the event across the electromagnetic spectrum. One of them being the Hubble, obviously, but that's not the only one who helped factor in some things. The clues. Using NASA's Chandra X-ray Observatory, astronomers observed X-ray emissions from a jet moving very close to the speed of light, produced by the neutron-star merger. Starting in early 2018, the jet's X-ray emissions steadily faded as the jet continued to slow and expand. Hajla and her team then noticed from March 2020 until the end of 2020, the decline in brightness stopped, and the X-ray emission was approximately constant in brightness. This was a significant clue. The fact that the X-rays stopped fading quickly was our best evidence yet that something in addition to a jet is being detected in X-rays in this source, said Raffaella Margutti, astrophysicist at the University of California at Berkeley and a senior author of the study. A completely different source of X-rays appears to be needed to explain what we're seeing. The researchers believe a kilonova afterglow, or black hole, are likely behind the X-rays. Neither scenario has ever been observed. This would either be the first time we've seen a kilonova afterglow, or the first time we've seen material falling onto a black hole after a neutron-star merger, said study co-author Joe Bright, also from the University of California at Berkeley. Either outcome would be extremely exciting. To distinguish between the two explanations, astronomers will keep monitoring GW 170817 in X-rays and radio waves. If it is a kilonova afterglow, the X-ray and radio emissions are expected to get brighter over the next few months or years. If the explanation involves matter falling onto a newly formed black hole, then the X-ray output should stay steady or decline rapidly, and no radio emission will be detected over time. Further study of GW 170817 could have far-reaching implications, said study co-author Kate Alexander, a CIERA postdoctoral fellow at Northwestern. The detection of a kilonova afterglow would imply that the merger did not immediately produce a black hole. Alternatively, this object may offer astronomers a chance to study how matter falls onto a black hole a few years after its birth. First images. The final chapter of the historic detection of the powerful merger of two neutron stars was written about 5 years ago in 2017. After the extremely bright burst finally faded to black, an international team led by Northwestern University painstakingly constructed its afterglow, the last bit of the famed event's life cycle. Not only is the resulting image the deepest picture of the neutron star collision's afterglow to date, it also reveals secrets about the origins of the merger, the jet it created, and the nature of shorter gamma-ray bursts. This is the deepest exposure we have ever taken of this event in visible light, said Northwestern's Wenfei Fong, who led the research. The deeper the image, the more information we can obtain. The light from GW 170817 was detected partly because it was nearby, making it very bright and relatively easy to find. When the neutron stars collided, they emitted a kilonova, light 1,000 times brighter than a classical nova, resulting from the formation of heavy elements after the merger. But it was exactly this brightness that made its afterglow, formed from a jet traveling near light speed, pummeling the surrounding environment. So difficult to measure. For us to see the afterglow, the kilonova had to move out of the way, Fong said. Surely enough, about 100 days after the merger, the kilonova had faded into oblivion, and the afterglow took over. The afterglow was so faint, however, leaving it to the most sensitive telescopes to capture it, which was the Hubble. Future sightings. So, as we've shown you, the Hubble Space Telescope has been doing quite a bit over the last few months and years to further showcase its worth. This is important because, as noted earlier, its replacement in the James Webb Telescope won't be active full-time until possibly June, and for all we know, there could be other hiccups that happen with it. That's why so many are okay with the Hubble continuing to do what it's doing, because it gives them the first steps towards understanding, and then, should they need more, they can just ask the James Webb to look at certain things later. And with two very good telescopes out in space, looking at space, who can say what wonderful things we will discover? So, what do you think? What do you think of this look at the Hubble and the new images that it's been capturing all over the place? Are you amazed that the Hubble telescope was able to capture something like this? What do you personally make of it? And what else do you think the Hubble is going to find out there as it looks into deep space? Let us know in the comments below, and we'll see you next time on the channel.